Welcome to our next talk. It's all about EclipseStore, ultra-fast Java Cloud native persistence for microservices. Thanks for joining. So in this session, you learn how you can build ultra-fast database applications without the need to use a database. So my name is Markus Kett. I'm CEO and co-founder of Microservices. And with my team, we work on Java for almost 20 years now. We started with a Java development environment. It's called EclipseStore. It's a kind of like Visual Basic for Java. To develop this project, we also worked on the JBoss Hibernate tools for many years and tried to improve the JBoss Hibernate tools. So we our team very experienced with Java database development with Java. We also work on open source projects for many years, JPA, SQL. Then we started the Microservices project. It's also open source from the beginning under EPL. And now we are super happy to announce that Microservices is now split into two Eclipse projects. One is Eclipse Serializer, and it's released already, so the final release is available. And second is EclipseStore, and it should be available as final release during EclipseCon, actually. So hopefully tonight during the party. We want to work on a standard for this functional principle. EclipseStore is already used by frameworks out there, so it's integrated with Helidon, which is a microservice framework. It's integrated with Micronaut. We have a really beautiful integration with Micronaut. And we have also integrations with microprofile compatible frameworks, and so Quarkus, for instance, and also for Spring Boot. So, why should we talk about persistence? What's interesting here? So, with big data and cloud, and now with AI, machine learning, so this is super popular these days, of course. All of these modern applications, they produce and consume tons of data, and the amount of global data is exploding. And for all of these nice, fancy, modern applications, there are three critical factors. The best possible performance, so we need high performance. We want to have low data storage costs and simple implementation for a faster time to market. These factors are obvious, so everybody wants best possible performance, right? And low data storage costs. In terms of storing and processing data, we are still using technologies invented in the 1960s. So the question is, are the databases of today fast enough? The programming languages, I would say, are fast enough. So Java is fast. Everything that's executed in memory is super fast. We talk about microseconds, execution time in memory. Databases, in comparison, are very slow. They are built for specific use cases, so the use cases are limited. They are very expensive in the cloud and lead to high complexity. So we worked on database tools for many years, so I love database programming, and I love tools like frameworks like Hibernate. But these are facts. And so why are databases slow, and why do they lead to high complexity? So I like to talk some minutes about these challenges. So here we can see an architecture of a common Java application. We have a Java application, a JVM, we have a database. As long as we program with Java, everything is great. So it's object-oriented, everything is in memory, everything is easy for us, type safe, great. So as soon as we want to store data, we obviously use a relational database. And the relational databases, they work fundamentally different from Java. So from a technical perspective, they are incompatible. It's not possible to store job objects in a relational database. It is not possible. We have a lot of mismatches here. I don't want to dive into deep. You can read more about this in the internet. So there are a lot of great articles in the internet. What about NoSQL databases? Who of you uses NoSQL databases? No one? Some. Who uses databases? Okay, relational, of course. Nice. So the NoSQL databases, now they introduce new data structure and formats. So this might be the biggest difference between a relational database and the NoSQL databases. We have the column store databases, we have document-based like MongoDB, JSON, we have graph databases like Neo4j or time series databases, and now the vector databases. All of these databases are incompatible with the job object model as well. We have the same issues here as well. You cannot store any Java object graph seamlessly in a NoSQL database. So what we're doing is, with a relational database, we add a framework like Hibernate that provides object relational mapping, and that we be able to store our objects in a database. With NoSQL databases, we need a kind of like conversion, data conversion, like JSON conversion, through every single read and write. That's crazy, actually. Data conversion and object relational mapping is very expensive. It leads to expensive latencies, and it slows down our applications. What we're doing in practice, mostly, we add a cache. So, back to our architecture. So, we add a local cache. Now, we can accelerate our database queries, because now we read the results directly from cache. That's great. Who of you is building distributed applications? All right. What's the challenge here? If we run our application on multiple nodes and we change some data on our node, store data in a database, then this node and the database are in sync. All the other nodes are not in sync with the database. How can we solve this in practice? Let's put the cache in between the application and the database. To avoid single point of failure, we use a cluster. This is a distributed cache, like Redis. Who of you uses distributed caches? Okay. Common architecture, but you can see now the complexity increases more and more. If we have much more load on our application and our database, we obviously want to run multiple nodes of our databases, so we need some replicas. So now we have 3 clusters running, high complexity actually, and in practice, we often see searching servers like Elasticsearch. Who uses Elasticsearch? Great. So we have a fast database, great database, but we use a searching server. Then we have a 4th cluster tier running, and just for storing data initially. If we add some computing features to our distributed cache, then we talk about the in-memory data grid. So we have the same architecture here as well for in-memory data grids or in-memory databases as well. We have pretty much the same architecture with in-memory databases. So we can see a lot of machines are required, and this is the reason why enterprise architectures are mostly so expensive in the cloud. So now with microservices, we have another challenges, because there are some rules with microservices, and one of these rules are each microservice that deals with data should have its own database. Okay, let's imagine we have a microservice that consumes sensor data. Which database you would choose for this microservice? Obviously, a time series database is suited. Okay, then we have some services, they have to process really complex data. Okay, we have graph database, then let's use a Neo4j. Perhaps we have some services, they of course have access to a big Oracle database. Then we have probably some other data, and probably a document-based database is suited for that. So multiple databases for multiple purposes. And this, again, increases the complexity of our system, and to test, to deploy, and to develop such systems is very complicated. It's expensive. All right. And databases as a service are very expensive in the cloud as well. So, for instance, PostgreSQL is a service at AWS, costs you around $3,000, depending on the machine size. Here's an example: 4 CPUs, 16 GB memory. PostgreSQL costs around $3,000 per year. If we need more replicas, more nodes to share the load, your price will double or triple. So for instance, 6 nodes cost you $18,000 per year. There are options, alternatives in the cloud. The cloud providers, they provide us binary data storages, blob stores or object stores, like AWS S3. Great thing here is S3, 250 GB, costs only $70 a year. That's it. You don't have to care for replication. You don't have to care for uptime. No administration effort. Super easy to use. And it's almost 99% cheaper than a database as a service. This is a fact. There are other facts about Java. Java is very fast, extremely fast, because we have a great JIT compiler. And Brian Götz said at Devoxx, with our great JIT compiler, we are able to sometimes outperform C programs. Wow, that's great. We are faster than C. And we have a great data structure. The databases, they have limited data structures, so because these are built for specific use cases. With Java, we have a multi-model object, a multi-data structure model. We have objects, object graphs. So we can store single values, we can store simple lists, but we can also create complex graph structure with circular references, billions of nodes in our object graph. We can consume sensor data, we can deal with vectors. Everything is possible in Java. That's great. And we have a great query language, Java Streams API. And with Java Streams, we are able to search an object graph in microseconds. Even if you have a terabyte of memory, data in memory, and a complex structure, it will take mostly only microseconds to search. The problem is there is no feature in Java to store objects. Now, imagine we could combine the power, the performance of Java and the power of the Java object model with the cheap object stores of the cloud vendors. And this is exactly what EclipseStore does. And with EclipseStore, we do pretty much the same like the JDK guys do with storing the state of a JIT compiler, Project Crack. Have you heard about Crack? Who has heard about Crack? All right. So they create a snapshot of the optimization of the JIT compiler, and we do pretty much the same with application data. And this functional principle is called system prevalence, and the functional principle is really simple. So this architectural pattern, it says, keep your data in memory, process your data with your programming language, and create a snapshot of the changes by using serialization. And then you have solved all problems. Probably. There are some challenges with this functional principle because of memory capacity. So if I have all data in memory, so it's limited. Creating a snapshot of the whole system state takes too long. Transaction safety is missing here. Schema migration, challenging. And so on. There are a lot of challenges. With EclipseStore, we have solved all of these challenges, all of these problems. And we have now a framework for that. This functional principle is already used by companies, by a lot of companies out there who need this high performance in their high-frequency trading applications, like the banking companies or a lot of gaming companies do it already successfully. The problem is they have to care for their own, for all of these factors, for all of these challenges. They did it, so because of it was business critical for them, but now with EclipseStore we have a framework. Now you can use it for all applications. What is EclipseStore in a nutshell? It's a persistence that replaces Hibernate, and it stores any kind of objects, any complexity and any size persistently into any data storage. Like plain files, we recommend blob stores like AWS S3 because it's fully managed, but you can also use plain files, of course. And vice versa, it allows you to load and restore any persisted objects and restore it in memory at any time. By using lazy loading, it allows you also to only load subgraphs in a memory and restore subgraphs. So you don't have to restore the entire system state. Of course, it's open source, it's an Eclipse project, it's under EPL, and you can use it for commercial purpose. Great. So how does it work under the hood? So back to our architecture. And here I can, so we dive into a database, because mostly it's recognized as a black box. So we just send an SQL to a database, nobody knows what happens inside the database. Here we can see we have, of course, storage. So we have a database management system, and a database works great with a lot of memory. A database server with 500 megabyte probably does not really work well. So you need a lot of memory, and so database also uses caching. We cache data in memory in our database server, and sometimes there is business logic, stored procedures and stored functions. Who of you uses stored procedures and stored functions? You're a Java developer. It's not covered by a JPA standard, so mostly we don't use it in Java. But database vendors put a lot of effort in stored procedures and stored functions. Why don't you use it? Yeah, so we Java developers don't need it. So JPA standard does not cover it, so we don't use all of these functions of a database. And with EclipseStore, we even use more or less functionality of a database server. So now we replace Hibernate with EclipseStore, or data conversion if you use a NoSQL database. We keep data in memory and we search in memory, which means we don't need a cache anymore, so we can skip the local cache. And we use the object graph in memory as an in-memory database. Because we have great data structure, we can do everything, we can search, so we don't need a database anymore, database management system. We care for validation, concurrency, so our business logic in Java cares for everything. We don't need a database management system anymore. The only thing we need is storage. and we store data in a binary format, so a blob store is really suited. So now I want to show you a small performance demo. This is a bookstore demo. And you can find the code on GitHub. You can check this out, play around. So 2 applications are running in parallel. One is built, so we use a PostgreSQL, 250 gigabyte storage. One application is built with Hibernate and cache. By the way, this application is running, which means the cache is hot. We have data already in memory. The other application is built with EclipseStore. And you can see the query code, and you can see we use Streams API for searching and filtering. And even when we fetch data from a hot cache, Streams API is much faster. It's even faster than reading data from a hot local cache. This is pure JVM power. Sometimes the queries are, it doesn't run, right? So it's frozen. I'm offline, sorry for that. So you can see this on our website. Actually, all of these queries are executed around 10, sometimes 100, sometimes more than 1000x faster than a comparable JPA query. So it's frozen, so let's skip it. So how does it work in practice? The object graph in memory is our in-memory database. And when you change an object, you just have to call a store method. And then we serialize the changes to disk. And this operation is an atomic all or nothing operation and transaction safe. We create a binary format by using the Eclipse serializer. So the format is open. And then we store the object appended to the file storage. So each operation is a new file in your file storage. So we never overwrite data. Even if you edit data, we store the changes appended to the file storage. We never store the whole object graph. Only the delta, only the changes are stored and serialized to disk. So this is high performant. Yes, please.
When you have a long running application, 1 million objects which have changed and stored AWS S3. When you have all this data, you have a user up and running. When you have a long-running application and you have 1 million changes, and after a long time, you have 1 million deltas inside your storage, and maybe I will run a new server of my clustered application, yep. And the application is connecting. The application will try to load 1 million objects to get all the data.
Of course.
Apply 1 million changes.
Of course. No, I'm kidding.
Okay.
No. So when you start the application initially, then the engine loads your object graph into the memory, but only a representation. Only the object IDs are loaded. Only the object IDs are loaded. No data. And then everything works like magic, fully object-oriented. You just call get methods. If the object is in memory already, you get the object from the JVM. If not, the engine loads the subgraph, the object reference, and merges your the loaded object directly in your object graph.
You always have a hollow. Hollow is filled on demand by lazy loading.
Yes. So you have an object graph in memory, but it's only a representation of the whole object graph. The object IDs are in memory, and so you call a get method, and then the engine loads dynamically the subgraph and merge subgraph in your object graph, and don't have to deal with object copies. This is how it works. So, and you can define your classes as eager or lazy. If you define it as eager, then the engine will load also data. If you define it as eager, as lazy, then data are only loaded when you use when you touch the object. When you never touch an object, then it's not loaded. So you can even have 250 gigabyte of storage size and only 4 gigabyte of memory. It will work. And you don't have to care for memory management. JVM does the job. You have full control of about your lazy references. You can clean your lazy references anytime. You can define a timeout or let the JVM do the job. So how does it work with distributed applications? So we can also run distributed applications with EclipseStore. Then we replace the nodes with the EclipseStore nodes. So now with the replication, we can now replicate the object graph through hundreds, thousands JVMs. And so we keep the data in memory. We don't need a distributed cache anymore. So if you use distributed caches with EclipseStore, you don't need it anymore. Because it works already like a distributed cache. We just use a blob store like S3, which means we don't need a database cluster anymore. So we can skip 2 clusters and we can skip a lot of machines. And CPUs are very expensive in the cloud. Storage is not. Storage is cheap. And so we have finally a plain simple architecture, core Java, no magic. And you can also run this Eclipse cluster with other programming languages. So if you can run it with let's say stateless serverless functions and query the EclipseStore cluster by using REST or GraphQL. So even if you have a Python application, you can query such a EclipseStore cluster. Who of you uses Python? No one. Great. So the end result is really a plain architecture and a super fast application. Conclusion. So everybody wants performance. And everybody wants low storage costs, of course, and easy implementation. But in practice, we use database systems, and the problem is they're incompatible with the Java object model, so we cannot avoid this mappings and data conversion through every single read and write. And this is very expensive, leads to expensive latencies, slows down our application. So, and to improve this, we add caches and search servers to build fast application. And this accelerates, and this increases our costs in the cloud. And this is the reason why all of these enterprise applications are so expensive in the cloud. With EclipseStore, we now replace this data conversion, object relational mapping, because of we just kind of like mirror the system state in a object storage, and this is super cheap. The architecture is very simple to develop, to test, to maintain. Everything is cheap, and the implementation is very, very simple. So there are also some cons, of course. So there are trade-offs. This is built for the JVM. This is implemented in Java, so it runs with all JVM languages. It runs also on Android. Who of you builds Android apps? No one. Okay, Android for a course. It works also for Android applications. The only requirement is Java version 11. So thank you, Florian, for the hint. And it runs everywhere where JVM is available, so in containers, even with native images, you can use it very easily. There are no requirements. So it's open source under EPL, and so we hope that now it's available for the whole Java community. You build great applications with EclipseStore, use it in frameworks, and make your development more efficient and productive. So, if you want to learn more, we hope that we will be able to launch the final release. So we're still waiting for it. Serializer is available already. Hopefully, we can launch it during EclipseCon. Everything is prepared. You can download it, check it out. If you have any questions, visit our booth, and have a great day and a great party at EclipseCon. Thank you. Any questions?
How does it compare to Hazelcast, for instance?
The question, how does it compare to Hazelcast? I'm not an expert in Hazelcast, of course. Hazelcast, as I know, is in-memory data grid. Yeah. So we are able to deal with all data structures. So we do not require key value structure, for instance. And we deal with all Java types. There are no requirements to your classes. So it's so easy to implement, just POJOs. There is no super class you have to use, no interfaces, no annotations. There is no interface to implement like serializable. There is no client API required for using it. So this is everything core Java and plain Java. And we believe, so we have tests already, and also partners have tested against Hazelcast also. And Java Streams API, so this is not EclipseStore. Java Streams API is much faster than access on Hazelcast cluster. But you should check this out. Don't believe me? Check it out.
Okay.
Yes, please.
I think when you are using Hazelcast, you have no SQL database, and you can use JPA to migrate your an SQL database approach to a NoSQL database approach, but you will still have the object relational mapping. So you give it to Hibernate or something else, and you have this object relational mapping between. When you are using EclipseStore, as if I get it, you don't have a JPA between.
Right.
You have just the object, and use EclipseStore to store it directly. No JPA, no object relational mapping.
Yep.
And this part is completely reduced. But I think when people want to use EclipseStore, they have to think about, we have to migrate because we have no JPA. We have to store it in another way. We have to use a kind of select statement because we use the Java API, the API streaming. And it's another approach. I think there's less overhead because you don't have the relational mapping, and it must be faster. But of course, you need a storage which is reliable. When you have an AWS S3 and it is reliable, and you don't host it yourself, and your hosting is bad, I think this is a very interesting approach, and it must be faster. But there are some caveats, I think.
Yeah, great conclusion. So it's recorded. Thank you for that. Absolutely. So this is the only storage solution where we don't have a mapping, don't have to map our classes to something else. So we wanted to avoid this. So no more mappings or data conversion behind the scenes. There are some challenges because it's a paradigm shift in database programming, but we are already, so there's no SQL support, of course, and so on. And there is no database server anymore. There are no classic selects. Everything is fully object-oriented, which actually should be an advantage for Java developers. And we already working on an integration with Spring Data, so to make it more easy to develop database applications in a way that Java developers are familiar with. So, but yeah, so it's a paradigm shift, definitely.
So how do you deal with, so let's assume you start with a data model, it has like 1,000 objects, then you add another 1,000 or something like that. How does EclipseStore deal with, like, you save it to the binary form again? Does the object just grow? Do you have some gaps in between? Like, do you have to fragment? Do you have a fragmentation of the storage at some point in time, or is this just a non-issue because you store it in a certain way on the disk or in the blob store? Is there any caveat to that?
This is a great question for our CTO. You can take the micro, Florian.
So yeah, that's a good question. We have to deal with this in the background. The JVM does it on a heap for us. So if you dereference objects, the garbage collector will take care of it. What we do is we have a similar garbage collector running on a storage level. So if you have fragmented parts in your file layer or binary layer, or older versions, so if you store a customer 3 times, the older 2 times are not needed anymore. That's what the housekeeping and the garbage collector of EclipseStore does, which runs in the background. It's fully managed, so the storage gets cleaned up automatically. Yeah.
Just again a question about storage. Did I understand it correctly? The garbage collector does handles thrown away objects when the object is no longer in the JVM and it will be deleted on the storage system. So you have no infinitely growing storage. When you have deleted all your objects and you use nothing anymore, you have nothing on the storage. Okay, thank you.
So in the back, I guess.
As you said, we could use EclipseStore in distributed applications. So I might have one node that changes some data and my change is replicated to the other nodes. Are there any means of controlling that replication has succeeded to deal with maybe potential latency, like a quorum or something, to make sure that the change has occurred and all the nodes are in sync? First question. And the second question is, how does this work with respect to the CAP theorem?
The cluster solution is eventual consistency. So this is our first approach, and we already are planning an option for full consistency. But this is more complicated because there are more levels of full consistency. What does full consistency mean? Sometimes it's full consistency if 50% of your nodes are replicated, or should all nodes be replicated? So there are multiple levels. This is more complicated, and this is the reason why we started with eventual consistency approach. So this is for reading applications and not critical applications like banking applications. Is not that suited. So it's more for reading applications than.
And with respect to network partitioning, split brain, does it have any built-in mechanism to deal with these bad situations?
Yes, the cluster solution cares for that, so that we don't run into a split brain issue.
Okay.
I was wondering with this solution, since it seems like you can get more granular permissions, can you use like IAM permissions or S3 permissions to set up what access different nodes will have? So let's say they can only read certain parts of the database and they can't access certain parts at all, versus some can do full read write.
So I guess you want to manage user access on a storage level of some sort. That's the part of the paradigm change. All control features move to the application. So you don't need a database server anymore. Your application is the database. And at the storage layer, you have no server instance of any sort. So the access logic or the access restrictions have to be implemented in your Java application. So you can use frameworks like Spring comes with a user access control library, which can adopt to LDAP or whatever, or OAuth or whatever control mechanism you want to use. But it has to happen in the application itself.
I imagine the application can have its own separate account credential. Following from that,
I'm not sure if I'm getting it right. So you're saying the
node has IAM credentials,
yeah.
service account, to access it.
Yeah, of course, the application has to have the rights to access S3. Yeah.
Capitalize on that.
No. So you see, the application has to know what user can access what objects, for example, or what type. It has to be implemented in the application itself. Yeah.
If I understand correctly, you're saying my application needs to restrict access to certain data to users. Within my data model, I will have to model access control lists or whatever objects.
Right.
Then use them in my queries, streams to
Right.
user
Yeah.
the content, memory, and just show to the current user what he can see.
Yeah, like a database does for you. Yeah.
It's because there is no more database server, so everything has to be implemented in the application. It's the same when you want to let third-party applications access your data. So there is no server anymore where third-party applications can get access directly to storage data. So you have to implement interfaces. So Java developer has to implement an interface. You can use REST or GraphQL for that purpose, so that third-party applications can have access to your application easily. But this avoids bad mistakes. So with databases, we often see that third-party applications have direct access to a database, and then we have problems with data consistency in the application. So it will destroy your application, actually. And this is not possible with the EclipseStore, because you have to implement an interface. All right, so if you have further questions, we are at the booth. Have a great day. Thank you. Thanks for joining.